Similar to number 15 on the review, we have this one question that says, sketch the graph of the polynomial functions and state the end behavior, maximum number of turning points, the intercepts, and whether the graph touches or turns at each x-intercept. Okay, so this is a long question with lots of things to find. Let's take it step by step through each thing, starting with the end behavior. To determine the end behavior, this is which direction the ends are pointing, we need two different pieces of information. We need the degree, and we need the leading coefficient. Okay, and as we did on another example before this one, we have to find the degree by combining all the powers together above each of these factors. So in this case, the powers are 1 plus 1 plus 2. Combining that together tells us that the highest power is 4, and that would be our degree, degree 4. The leading coefficient is in the very front. In this case, you don't see a number, so it's an understood 1 out in front. Now to determine end behavior with these numbers, we look at the degree. We see that it's an even number. We look at the leading coefficient. We see that it's a positive number. And this will tell us which arrows to use for each end of the graph. If the leading coefficient is positive, then this end will point up. If the leading coefficient is negative, this end will point down. So in our case, it's a positive number, so that end will point up. The other end, if the degree is an even number, the other end will point in the same direction as the other arrow. If the degree is an odd number, then it will point in the opposite direction from the other arrow. So since in our case we have an even number for the degree, that's going to tell us that this arrow will point in the same direction as the other. So they're going to both point up. And that's our end behavior. Now to determine the number of turning points, all we need to do is take the degree and subtract 1 away from it. So our degree is 4, and minus 1 tells us there is at most 3 turning points in our graph. And now we're going to find the x-intercepts. That means we set the whole thing equal to 0 and solve for x. Since this one's already been factored, we can just take each one of our factors and set each of these factors equal to 0 and solve for x. This one, we subtract the 1, we have x equals minus 1. Here we subtract the 3, x equals minus 3. Subtract the 5, x equals negative 5. Now it asks us in there to see if it touches or crosses at each one of our x-intercepts. And that's going to be based on the idea of the multiplicities. So for each one of these, we'll write down their multiplicity. And again, multiplicity comes from the powers above each of the factors up here. So this one has multiplicity 1, this one is 1, and this one is multiplicity 2. Since these are odd numbers, for multiplicity, these are going to cross at those intercepts. Since this multiplicity is an even number, then we'll get the touch and turn at this intercept. Alright, so we got our 3 intercepts and what's going to happen at each of those intercepts. The last intercept to find is the y-intercept. For this one, we're going to plug in a 0 for x, and run the numbers to see what that's equal to. Here we're going to get 1 times 3 times 5. And that's going to be equal to, to 5 squared, sorry. 5 squared, that's going to be equal to, looks like 3 times 70 or 25, which is 75. So that gives us our y-intercept of 0, 75. Now we've got all the stuff we need to draw the graph. So we'll scroll down here, lay it out with our intercepts. Intercepts are all negative numbers. We got -5 here, -3, and -1 for our x-intercept. We'll just make a mark up here in the y-intercept and call it the 75. Now our end behavior is both ends are pointing up, so this end's pointing up, it comes down to -5. We have written down for that one, touch and turn. So it's not going to go through, it's going to turn, come back up, go down. We had written as cross at -3, so we got to go through, come back up and cross at -1, and then continue to go up from there. And that's it. That will be the sketch of this graph.